Hello, Math 8 students. This is Utah Middle School Math Project 2.2e, more representations of a linear context. What does that word mean? Linear. We just saw it a few minutes ago in class. Linear, what does that mean? Siley. Straight line, yes. Linear means straight line. So that means each one of these will be straight lines. And because it's a straight line, we're also going to be seeing something that we'll address later in a later problem. The situation is the state fair, and it gives us a context. Table, graph, equation is all blank, and then there's even some questions that follow. So we need to build our own table, graph, and equation based on just the story or context. You and your friends go to the state fair. It costs $6 just to get into the fair, and $2 each time you go on a ride. So let's build a table to really make sense of what's happening. Let's start with the labels. I want the first part of the table to always be labels. What am I going to be measuring? Yes, there's going to be an X and a Y. We know that. That's going to help us when we write the equation. But what are we going to be measuring in this first column? Sam? Yeah, the number of rides. And so if the number of rides is in the first column, that makes what in the second column, Gabe? Yeah, the cost, the money. So chances are you're not just going to go to the fair and ride no rides, right? You're probably going to ride some rides. But what if you rode 0 rides? Like your mom, who has the baby in the stroller and everybody's water bottles, who doesn't get to go on the rides because she's taking care of everything, right? How much did she still have to pay to get into the fair? Jaden? $6. So it costs $6 just to get into the fair, even if you do nothing else. Even if all you do is go buy cotton candy and popcorn, you still have to pay the $6 just to get in. But chances are you're not just going to be riding 0 rides. Chances are you're probably going to have a good time and ride at least 1 ride. What does that mean? What is your total cost now after riding 1 ride? Because it does say that it costs $2 each time you go on a ride. So is that going to be a 2 here? What do I do with that 2 then? Because I feel like that's right. $2 each time you go on a ride, 1 ride, $2. Emma? Exactly. We add it to the 6. It's $2 extra because we rode 1 extra ride. So 6 plus $2 is 8. So what if I ride 2 rides? What is that going to be? 10? Why 10? Maverick. 6 plus 4. Why did you do 6 plus 4? You're right, but why 6 plus 4? Go ahead. Yeah, 2 rides. And 2 rides is going to be $4. $2 for this ride and another $2 for that one. So 1 more ride means $2 extra. And you get the idea, right? Let's go 3. 3 rides. I'm going to guess at what's happening here. 1 more extra ride means we're paying an extra $2. So the grand total cost is going to be $12. You can continue on going in order 0, 1, 2, 3. That's fine. I'm like doing 5 and 10 as well. After we see what's happening with the 0, 1, 2, 3, skip around a little bit. And what is that going to be? This is where we really got to challenge our brains here, because you're going to notice this is not proportional, right? It's not going to be going through the origin. And so we can't find a constant of proportionality, so we need some other strategy to help us fill in those blank spots. What are your thoughts? Let's start with Seth. What would you do? Ah, great job. Because we're going on 5 rides, right? So when I go on 5 rides, that's $2 for each of those rides. But remember, we're not just paying for the rides. We also have to pay an extra $6 because we got into the fair. Great job. So 5 multiplied by 2 is 10 plus 6 is 16. Another way that we can look at this, and I love that strategy, that leads very nicely into our equation. How is that 3 changing to a 5? We added 2 extra rides. And if I add 2 extra rides, that's going to be $4 extra. 12 plus 4 is 16. 10 rides, skipping all the way to 10 rides. How much will those 10 rides cost? Gabe? $26, because 10 times $2 for each one of those rides, plus the extra $6 it took to get into the fair, gives us a total of $26. Now, if your table doesn't look like mine because you chose different values, that's fine. But for any of our values that match, I hope that the cost also matches. Let's move on to the graph. Something I really want students to get in the habit of. Please understand that this is the x-axis and this is the y-axis, but I don't want to just see x and y labels. What is my x variable representing? Siley? Number of rides. So let's add that label to our x-axis. Don't just call it x, let's call it the number of rides axis. And the y-axis then isn't just going to have the variable y, it is also going to have the label of cost. We need to figure out the best way to scale our graph. I feel like for the most part, for many of these problems, it's okay on our x-axis to count by ones. And it makes sense for the situation. We could ride 1 ride or 2 rides or 3 rides, etc. That makes sense. What is the best scale? There's multiple scales that we could use, but what is a best scale to use for the cost? Looking at the values that we have, understanding the situation, what do you think is going to be best? Daxton? We could count by 4s, absolutely. Jaden? 2s? Yeah, it would work. Fits? Yeah, 2s or 4s I think is best. If we count by 1s, we're not going to see as much information as if we count by something like 2s or 4s. And I'm not going to be picky on that at all. If you want to count by 2s, count by 2s. If you want to count by 4s, count by 4s. I, personally, am going to count by 2s. So 2, 4, 6, 8, 10. Remember, it's okay to be a little bit lazy and skip some lines. You do not have to put a label on every single one of those marker lines, but I need to at least see that we have acknowledged what we're counting by. And now it's time to put on some points. The first point is the initial value, or the y-intercept, over 0 and up 6. So over 0 up 6 doesn't mean we're going up 6 boxes. Over 0 up 6 means we're going up 2 where we marked 6. 2, 4, 6 means we're going up just those 3 spaces. And 1 ride costs $8. That's going to be right here. 2 rides, $10. 3 rides, $12. 5 rides is going to be $16, etc. Now, if you would like to, you can put a single point on every one of those. But the whole point of this is these are linear relationships. So if it's a linear relationship, that means we can make a nice straight line. Any questions so far? Then let's write the equation. The equation should come easy after our last couple of lessons. What is the slope? What is the y-intercept? I identify those things first. The equation should be in the format y equals mx plus b. M represents the slope. What is the slope? 2. It's 2. You can say 2 over 1 if you want to. You can just say 2, because 2 over 1 does simplify to 2, and that's fine. So y is equal to 2x. But it's not exactly multiplying by 2. We also had to add $6 just to get into the fare, so that b value, that y-intercept, is plus 6. What is the rate of change in this problem, and what does the rate of change represent? We just summarized what rate of change is before we started this recording. Students in class, what do you remember? What is rate of change? What are we really talking about? Maverick. Now that would be the constant of proportionality. The constant proportionality is what takes me from one side of the table to the other. However, 2 times 5 is 10, and that doesn't work here. 3 times 5 is not 12. So this doesn't have a constant of proportionality, and it shouldn't because it's not going through the origin. However, we can still figure out the rate of change. Look up those notes that we just used to summarize. Jaden? Exactly. Rate of change, you'll remember from our last lesson. Where do I find the rate of change if I'm looking at a graph? It's the slope. It's the rise over run. Where do I find the rate of change if I have a table? It's comparing the change in the y values to the change in the x values. So just as Jaden said, it's $2 for every 1 ride. $2 for one ride. Also known as 2. Where do you see that 2? In the equation right here. It's multiplied by the x. So no matter what representation you have, whether you have a graph looking at the slope up to and over 1, whether you have only the equation, it's what's multiplied by the x, or a table seeing how the y values change compared to how the x values change, or even just a story, it's changing $2 each time we go on a ride, you can find the rate of change. Now, it does not have a constant proportionality, no, but it does have a consistent rate of change. Every time we go on a ride, it's an extra $2. What is the y-intercept on the graph? That's easy. We can see that it's intersecting the y-axis at 6. So that would be the point 0, comma 6. What does that represent? What does it represent in this context? y0, comma 6. Have a quick discussion at your tables. Okay. What does that 0, comma 6 mean? It's where it crosses the y-axis, yes, but what does it actually mean? Danielle? Yeah, it's the starting point for this. It's the entry fee. Costs $6 even if you're just going to enter and not ride any rides. So what does that really mean? It's our $6 entry fee. $6 to enter. Even if we ride 0 rides. And I love how you made sense of it with the context. Why would it be 0 rides is still $6? Because it's an entry fee. I like that. So here's where we can really make sense of how much we understand this. How would the context, meaning how would the story need to change so that we could represent it with just y equals 2x? What would have to be different about this situation? I don't want to see the hands yet. I want to hear good conversation at your tables first. What would need to change in the story? Okay, now come back to me. Tell me what you think. Good, happy to see some extra hands this time. Porter. Yeah, no entry fee. One thing that I want you to understand, y equals 2x and y equals 2x or mx plus b, they're still in the same format, right? We can still see that that m is 2. What is it that we're missing? We're missing the b value. That would be a plus 0. So what does that mean? Now it's free to get in, or it would cost $0 to get in. And now with that in mind, how would the story need to change if the equation is y equals 6 now? Y equals 6. What would have to change? Talk at your tables again. Okay, now come back and tell me. What would be different? What would change here? Ethan. Exactly right. We only have to pay to get in. Only pay to get in. Rides are free. So again, notice it's in the same format. It may not look like that, but it's because it's 0x, meaning it costs $0 for each ride. The only thing we're paying for is just the fee to get in. So these are still in the same format. It may not just look like it because the rate of change is 0. It's not changing at all. And 0 times x is 0, and we're lazy, so we just don't write it. Okay, the next one is another story. Let's just quickly flip through and see what different types of problems we have. The next one is a story. Great to practice since we just did a story, but then we start switching things around. Number 3, instead of a story, I give you a table. But you need to take that table and then create your own context or create your own story. We'll practice that in just a second, but here's the key things that I want you to be aware of when you are creating a context. At time 0, the cost is $7. So your story should be something about we're starting at 7 for some reason or another. And what's happening? How is it changing? 7 changes to a 9 by adding 2, just like a 9 changes to 11 by adding 2. So it's increasing in cost $2 every time the hours increase by 1. So in your story, it would have to be we're starting at 7 for some reason or another. We're increasing by $2 for some reason or another. Okay? So keep that in mind as you're writing your story. Let's move on to the next type of problem. This time, no story, no table. All I give you is a graph. Okay? And there's no labels at all. I don't tell you what the X represents. I don't tell you what the Y represents. You just need to come up with some situation where it would be decreasing by this amount. Okay? Notice where it's starting. We can still see the starting value or the initial value, the y-intercept. Let's quickly, while we're all on the same page, find the slope of this one. Let's make sure we understand. What is a slope? Is the slope really -1/1? Pay attention to that scale. What's the slope, Fitz? Yeah, -10/2. And -10/2 simplifies to -5 or -5/1. Good. So take that into consideration as you're writing that problem. And the final one, all I give you is an equation. Let's look at that equation. Tell your table, where is this starting and how is it changing? What would I need to write in the story? Okay, looking at this equation, it has some clues. Where is this going to start? What's the initial value? What's the y-intercept? There's not quite enough hands, so go back and talk with your tables again. I need a little bit more. I need to know who can understand this and who can't. Should we try it again? Where am I going to be starting in this problem? Thank you. That is better. Brock. Yeah, we're starting at 10. 10 is that initial value or that y-intercept. So we're going to start at 10, and what is going to be happening? How is it going to be changing? Jaden. Say that again. No, the equation does tell us how it's changing. We don't know what the situation is, but we do know that it's changing. By how much is that 10 going to be changing each time? Emery, help him out. By 4, because, notice, Jaden, the slope, that m value, that rate of change is 4. So we're starting at 10, it's going to be changing by 4 every time. Again, what you do in your story might be different, right? Okay. That's it. The rest is going to be homework, right? So just for this in-class lesson, you see the different types of problems that we're going to encounter. Different pieces of information are given to you, but for each one, let's just return to number 2. Do you see these questions at the bottom? Don't skip those. That's where it really all comes together. That's where we can really challenge ourselves and reach that deeper level of thinking. In each one, I'm asking, what is the rate of change? What does it represent? And what is the y-intercept? And what does it represent? Make sure that you're answering each one of those. And then, of course, there's always going to be some sort of a challenge, like going a step further. What if we do this? What if we do that? So go ahead and give number 2 a try. You are welcome to work with your groups. You're welcome to work independently, but give this one a try and we'll come back together and do it together in a second. Okay, students in class are working, so I am just going to record over the sound of their voices. Hopefully that's not too distracting. You are taking a road trip and you start the day. I'm seeing the word start. That gives me a clue that that's probably the initial value. You start the day with a full tank of gas and your gas tank holds 16 gallons of gas. On your trip, you use 2 gallons per hour. So we know how it's starting, our initial value, and we know how it's changing. So when I'm over here, I'm going to use some labels, still going to use our X and our Y. The X is going to be the number of hours that I'm driving. And the Y is going to be how much gas I have left in the tank. And this is an important distinction. If it's gas that is left in the tank, we need to understand that when I haven't even started driving, since I am starting with a full tank of gas and that's 16 gallons, I'm starting really high up at 16. And throughout the day, something is happening. 1 hour later, it says it's changing by 2. We're using 2 gallons. If I'm using 2 gallons of gas, that means 16 was in the tank. Using means it's going to be decreasing. So 16 minus 2 is going to be that value of 14. Another hour has passed, so that means when another hour goes by, another 2 gallons of gas will have been used. So 14 minus 2 more gallons is equal to 12. We can continue on with this pattern. 12 minus 2 is 10. Go ahead and skip. I like to skip ahead sometimes. Now, notice what's happened here. 2 hours have passed, and if 2 hours have passed, then I've lost not just 2 gallons, but 4 gallons. So 10 minus 4 is equal to 6. And same thing here, 2 more hours have passed, so we have lost 4 more gallons, and 6 minus 4 is equal to 2. How are we going to graph this then? This is our x-axis, and this is our y-axis. Our x-axis, remember, is measuring hours, and our y-axis is measuring gallons in the tank. An appropriate scale, I think it's okay to continue to count on our x-axis by ones. Knowing that we need to start at 16, that's our y-intercept. I probably should not count by ones because I don't think I'm going to be able to get up quite high enough. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No, not quite. So let's count by twos. 2, 4, 6, 8, 10, 12, 14, and 16. And now I'm ready to plot those points. Remember, the first one is over 0 and up 16. We're starting with 16 gallons of gas. 1 hour later, so I'm going over 1, I've decreased 2 gallons and continuing on in this process. Notice this is a linear relationship, so I can just do a nice straight line to graph all of those points without having to draw each individual point, and that is my graph. This equation is different than our last one. It still is going to be in the form y equals mx plus b, but here's how it's different. The rate of change is 2, but it's going down. So y is equal to a negative 2x plus we are starting all the way up at 16. Our initial value is positive 16, but the change, the slope, the rate of change is negative 2. You can see that here in the graph. Negative 2 and over 1. So with that in mind, what is the rate of change in this problem? The rate of change is the slope, negative 2 over 1, or simply negative 2. What does it mean? It means we are using 2 gallons of gas every hour. So what is the y-intercept of the graph? We can see that it's intersecting the y-axis right here at 16. So the y-intercept is 0, 16, but what does it mean? It tells us in the story too. The gas tank holds 16 gallons. So when I haven't even started driving yet, at driving for 0 hours, we still have 16 gallons of gas. So before we start driving, we have 16 gallons of gas. So how would the equation change if instead the gas tank held 18 gallons instead of holding only 16 gallons, and we used 2.5 gallons per hour instead of 2 gallons per hour? So understanding these and how we can identify those pieces here in the equation is going to be really, really helpful. We have a new starting value of 18. So y equals mx plus b. That new starting value is now going to be 18. and it's changing 2.5. So instead of changing down or -2, subtracting 2, we're subtracting 2.5. So the equation is now going to be y equals -2x, y equals -2.5x plus 18. That is it for this recording. Of course, there are more problems, but that will be saved for another recording. You're welcome to try some of the practice problems from the homework, but this lesson is going to be continued for another day. That's it for today. Thanks for watching. We'll see you next time.